All right, another video about probability and independent events. This is statistics and probability, outcome 4 and 5. So probability means when the outcomes of an experiment are equally likely. So there are two extremes when it comes to probability. There are the impossible events and the certain events. All right, so if we're talking about an impossible event, the probability that it will occur is 0 or 0%. On the other side, the probability of a certain event happening is 1 or 100%. So on a number line, an impossible event would be here. And a certain event would be here. So we are also looking at all the numbers in between as being possibilities between 0 and 1. All right, let's look at this scenario. So Sven has 20 felt pens in a pencil case. He has 7 blue, 6 red, 3 yellow, 4 green. Sven reaches into the case without looking and pulls out 1 pen. Describe the probability that he picks either red or green. So when we're trying to find the probability of this occurring, we're going to look at the number of wanted events over the number of possible outcomes. So the wanted events is that he either pulls out a red or a green pen. So we're going to look at that. That's what we want. So that's 6 and 4 over possible events. Well, there's 20 felt pens total. Right? So the part over the whole. So let's continue with this fraction. Get 10 over 20. And got to reduce that fraction. Right? And that's our probability expressed as a fraction. Probability is 1 over 2, written as a fraction. We also need to express this in a ratio and a percent. This as a ratio is 1 to 2. And this as a percent is 1 over 2 is 0.5. 0.5 times 100, 50%. Awesome. Now do the practice on page 282. Now let's look into independent events. Two events are independent events if the result of one event does not depend on the results of the other event. So let's look at two independent events. So you have these planes. You have 2 purple, 1 green. You're going to put them in a bag. So they're in a bag. The chances of pulling out a purple are 2 out of 3, right? So independent event, 2 out of 3. So I pull it out, 2 out of 3 chances that I pull out purple. And I got a purple. Now, an independent event means that I put that purple one back in. All right, and then I pull again. When I start it up and blah, 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 and I pull again, and I get purple. But the probability is always the same. Opposite of independent events is if I keep this one out. Now the chances of pulling another purple are not 2 out of 3 anymore. No, because now there's only 1 purple and 1 green left in there. So it's a 50-50 chance that I'm going to pull purple. And that's not independent events. Independent event, I always have to put this one back into the bag. Always, always. So let's look at this example. What is the probability of rolling an odd number and spinning yellow? So I don't have a spinner. I'll have to use our imagination for that. But a tetrahedron dice looks like this. There's only 4 options on it. And you would roll it and whatever's on the bottom, so I rolled a 2, is what you get. So you roll it every time. And that time I got a 4. This time I got 2. But each of these are equally likely, remember? Where the outcomes of an experiment are equally likely. Alright, so the way we're going to solve it is by using a tree diagram. Tree diagrams show all of the possible outcomes for an experiment with 2 events. 1 event, 2 events. Alright, so we get all of them and then look at our desired outcome. So you start making our tree diagram. We start here, and then we're going to roll our dice, our tetrahedron. If we're rolling it, we have 4 possible outcomes. So we list all 4 outcomes. So this will look like a tree in the end. 4 outcomes. And then, oops, sorry, you couldn't see that. So we list all 4 of our outcomes for the dice. Now here, each time we spin it, there's 3 total outcomes. But let's say you rolled a 1, and then you spin it, each of these is going to branch off. So, I don't know, that was kind of a confusing way to explain that. But what it'll look like, you roll that 1, and then you spin. So then you could get blue, yellow, or pink. Those are your possibilities. Whoops. From that one. And then the 2. So let's say you roll a 2. And then you spin. You can get blue, yellow, or pink. So there's 3 outcomes stemming from that one. And then you roll a 3. Same thing. You roll that 3, and then you can spin either blue, yellow, or pink. Stems from there. And then you roll that 4. Same thing, you spin it, and you can get blue, yellow, or pink. So that is what a tree diagram looks like. And from that tree diagram, all of this here, so possibilities are 1 and blue, 1 and yellow, 1 and pink, 2 and blue, 2 and yellow, 2 and pink, 3 and blue, 3 and yellow, 3 and pink, 4 and blue, 4 and yellow, 4 and pink. This is called our sample space. All of our total outcomes. Count them up. That's a total of 12 possible. Count them up, you can get a total of 12 possible outcomes. We have our total outcomes here. Now, let's look at what our desired outcomes, the wanted event. Well, we want to roll an odd number and spin yellow. So I like to circle or highlight the desired outcomes. So odd is here and odd is here. Odd and yellow. Right there. Odd and yellow. Right there. So it's only 2 outcomes. Remember when we talked about fractions being part of a whole? Well, we figured out from our sample space that it is, our whole is 12, and our desired outcomes is only 2, right? And then we need to express it again, express probability again as a fraction, a ratio, and I'm going to put percent over here. So as a reduced fraction, 2 over 12 equals 1 over 6, right? Divide this by 2, divide that by 2. Helps us get our ratio of 1 to 2. Sorry, not 1 to 2, 1 to 6. And then our percent, 1 divided by 6 is 0.17. 0.17 times 100 is 17%. And that's how you get the results or the probability of 2 independent events. Now please do the practice on page 287. So that concludes the notes for probability and independent events. If you have any questions, this is a lot, Grade 7s. Any questions, you email us. All right? See you later. Peace out.